class, and welcome to lesson 2.2, graphing sinusoidals. So what we're going to be doing is taking a look at translations today, which means how does a function shift up, down, left, or right? You should remember that we did some of this in grade 10 as well as in grade 11 with different types of parent functions. Let's just do a quick warm-up, and that's what you're going to find some days I do warm-ups, just to get us ready for our actual lesson. So here's warm-up 2.2, and number 1 says to draw a sketch of a parabola, of the parabola for each quadratic function. So hopefully you remember that this is called the base function, the first one, or the parent function is what you should remember from grade 11. What does that mean? That means that that expression is in its simplest form. And hopefully you remember that when you take a look at a parabola from that, it's got the patterning 1, 3, 5 from the origin, both left and right. All right. Let's take a look at the next graph. The next graph says, hey, we're going to take that expression and we're going to add 2 to it. So what does that do, ladies and gentlemen? That shifts it up 2. So our parabola gets shifted up 2. And what does that mean? That means C, which is one of our transformation or translation letters, C equals 2. So we're just shifting it up 2. Likewise, in the third one, when we have y equals x squared subtract 2, we're actually bringing it down 2. Okay? And again, you do 1, 3, 5. So in this case, C equals -2. And that's your up or down movement. Okay? Looking at the last two, notice there's a difference in the equation. The values of 2 and -2 are within the brackets. And that deals with the horizontal shift left-right. So looking at this, remember, ladies and gentlemen, that it's x minus p or x minus d in your equation, depending on which one you're using. So the actual value here is d equals 2. So what does that mean? We're taking our parabola and we're shifting it 2 to the right. All right? Whereas looking here, ladies and gentlemen, remember the equation is x minus d. How does the negative suddenly become a positive? That means that d itself has to be negative. It's opposite of what you see in the brackets, so you should have figured out a method by grade 10 or 11 to figure that out. So in this case, this translation shifts it 2 to the left. All right. So now that we've done a quick review, let's just recall your transformation formula from grade 11. So what does it say? We can apply transformations to any function, and we use the letters A, K, D, and C. Today we're just going to focus on D and C, which is the translation form. That's your up, down, left, right movement, or your horizontal and vertical translations. And the next class, we're going to focus on the A and the K. And the A and the K does your compression, your stretches, and your reflecting. All right, so let's take a look at D and C. It's important to analyze this, folks, because we're going to take this into sinusoidal functions for today's lesson. So D tells us the horizontal translation. Okay, if D is greater than 0, then it's going to move right, how many ever units D is. Okay. If D is less than 0, okay, or negative, it's going to move left D units. And just remember, in your equation, it's going to look like x plus d squared. Okay? So when it's less than 0, it's going to have a plus sign there. Okay? So make special note of that. All right. Now the C, ladies and gentlemen, it deals with not your horizontal translation, but your vertical translation. Okay, going up and down. So if C is greater than 0, you're going to move. Sorry, let's try fixing that up. Sorry guys, my eraser is wide today. So vertical translation, and if C is greater than 0, we're going to move up C units. And if C is less than 0, or is in that case negative, it's going to move down C units. All right, so hopefully you can, and just remember guys that we're going to do the A and the K part next days. Okay, so now we're going to apply the vertical and horizontal translations. And again, your vertical translations is your C, and your horizontal translations is your D. And we're going to apply those to our sinusoidal functions. So I know last day we were drawing the sine x curve and the cos x curve. Now we're going to be shifting it left, right, up, and down. All right. What you will need for this, ladies and gentlemen, is you will need to have a couple colored pencil crayons, as well as access to a graphing calculator on the computer. So if you have that graphing calculator simulator, please open it up and we will get set here. So to help you with my lesson, I'm going to be flipping back and forth to help you with this. All right, so we're going to use the graphing calculator to get us started, and then I'm going to flip back and forth, excuse me for that, flip back and forth to write stuff in on the lesson. All right, so the first thing we need to do, folks, is to make sure our calculator is in degree mode and that we've got our windows set correctly. So just a quick refresher, guys, if you're not sure how to reset your calculator, you're going to press second function plus sign 722. That'll say default set. We're going to press second function plus sign 4, enter. That's going to clear our list. We then go to y equals, make sure there's no equations in there. If there is, press clear and the down arrow. And clear and the down arrow, just to clear everything up. Okay, and the last thing we want to do is go to our mode and check degree. So go to mode, okay, and notice mine's in radians, so I'm going to go down and change it to degree mode. So press enter. All right, good with that? Okay, at the top of this it says to change your window settings, so we go to window, and it says to go to negative 360, not your subtract sign. So it's the negative one right beside enter. Okay, 360. Then we're going to have a scale of 45. Our y minimum is negative 4. Our maximum y is 4. And the rest stay the same. So what we have, folks, is a window that's going to be easy to see our graphs. All right, so the first example says to graph y equals sine x. I'm just going to clear the history here so everybody can see it. So go to y equals, and then you're going to use the sine and then the xt theta n button and close it. Okay, and then when you hit graph or press enter, okay, and press graph, here it comes. Okay, so what I'm going to do is flip back to the lesson, guys, and I'm going to graph that on here. Okay, so the key parts to remember for sine x, and I'm going to color code these. So we start, sine x starts at its axis. It goes to its maximum, comes back to its axis, goes to its minimum, and comes back to its axis. Okay, only problem I forgot to do is that we are only going up 1. Okay, and that pattern continues. So just remember, it's a continuous function. So we draw it all the way through. So a nice curve. And make sure you have arrows at both ends. Okay, so that's our sine x curve. Now we want to do sine x plus 1. So I'm going to flip back to my graphing calculator. I'm going to go down to y equals, and I'm going to go down to my second one, and then I'm going to press sine x plus 1. But before I graph it, ladies and gentlemen, I'm just going to go to the very beginning, and I'm going to press enter once, just so that I can see a thicker line. Okay, now I'm going to press graph, And you'll notice what's happened to that sinusoidal graph of sine x. It's actually shifted up 1 in every cases. Okay, so I go back to my graph. Okay, and I'll use blue this time. Okay, again, you can choose whichever color you want. Okay, and again, what's happened, instead of being on the axis, I'm going to start up at 1. So from each of my key points, I'm just going to increase it by 1. Okay, I'm just going to refresh my graphing my eraser because it likes to go big on me. All right. Okay, so again, draw a nice smooth curve. Okay. What do we notice, folks, is that the axis is no longer at y equals 0. The axis is at y equals 1. All right. You wanted to put your axis in here. Just so you guys can see it. All right. So can anybody predict what's going to happen in the third example where it says y equals sine x minus 2? Hopefully you predicted that things are going to go down 2. So let's go back to our graph. Let's go to y equals, and I'm just going to go to my second one. I'm going to leave it as is, except I'm going to change the last 2 values. So I'm going to go minus or subtract 2. Okay, I'm going to press graph. So here comes my parent function, which is sine x. And then our transformation or translation shows that the graph is exactly looking the same, but it's been lowered by 2. Okay, let's go back to our graph, and I'm going to use red this time. So we're just going to bring it down 2. So what does that mean, folks? My axis is now going to be y equals negative 2. All right. So we do a nice smooth curve. Take your time with these graphs because they're going to be helpful when you need to study for your test. And please try to use color if you can. And make sure you have arrows on both ends. Okay, so again, our axis is y equals negative 2. Okay, so let's just recap, guys. When we have y equals sine x, c equals 0. That means our axis is y equals 0. When we have sine x plus 1, c equals 1. That means our axis is y equals 1. When we have sine x minus 2, we have c equals negative 2, which means our axis is y equals negative 2. So far what we've learned is that the axis is the equation y equals whatever your value of c is. Let's see if that holds true in our next example that we do. All right, so now we're going to do the exact same thing looking at c, or our vertical translations, but we're going to use the parent function cos x. So let's go back just one second, folks. I'm just going to pause it here. Sorry, guys, they were just announcing a whole bunch of people. I didn't want you to overhear that. So again, guys, we're now going to take a look at example B. We're going to go to our graphing calculator, go to y equals. We're going to change cos x to, or sine x to cos x. Okay, and I'm just going to delete my second one for now. So let's take a look at that graph, folks, when we graph it. Okay, the curve looks similar, however, we call it a different starting point. So what we have to remember about cos x is when we start to graph, ladies and gentlemen, if I take my parent function here, we start at its maximum. So it goes maximum, axis, minimum, axis, maximum. Okay, and you follow that pattern as we go. So again, we do a nice smooth curve. Okay, and again we have our arrows. And again, our axis, or our equation of axis, our axis equation is y equals 0, or equation of axis, I did say that right. All right, let's take a look at our next one. What do you think is going to happen to our cos x? It says cos x plus 3, so hopefully you know it's going to go up 3. So let's try that on our graphing calculator first. So go to y equals, go down 1, go cos x and plus 3. And oh, I apologize. Let me clean one of these up. Delete. Okay, and I'm also going to go over, change it to be a little thicker just so I can see it better. And then we're going to graph this. So again, we've got our parent function, which is the cosine x, or the cosine function, and it's been raised 3 times. So let's do that on our graph. So again, we notice that if we started originally with our parent function at our maximum of 1, now we're starting at a maximum of 3, because it's 3 up. Okay, so again, you go maximum, axis, minimum, axis, maximum. All right. So it's important that you're drawing these as we go, folks, so you can develop the patterning. Again, a nice smooth curve. Oops, I missed a bit there. Sorry. Okay. And what do we notice about our axis here, guys? We notice that y equals 3. Okay. So again, if we start at our maximum, we're actually at 4. I think I said 3 by accident, so that's at 4, guys. Okay. And what you need to know, folks, is when you have a cosine curve, you start at your maximum, okay? But it depends your maximum based on your amplitude, and we're going to get into that the next day. So it's the amplitude plus your starting point to get to there, okay? To get your starting point. So we'll go over that once we deal with A and K first, because that's going to make things a little more difficult. Let's take a look at our last example, C, folks. I think we could do this one without graphing, but we'll do it first and then we'll graph to double check. It says cos x minus 1, so from your parent function, you're just going to drop everything 1. Okay? So again, you drop 1 for everything. Draw a nice smooth curve. Okay, put arrows on it. And again, what do we know about our axis now? Our axis is y equals -1. So let's just recap this, folks. When we've got our parent function, c equals 0. When we have our second example, or our blue graph, we've got c equals 3. And when we get our last graph, we have c equals -1. All right, let's make some conclusions about the C value. So what do we know? First of all, C deals with a vertical shift. Okay, and they call vertical shift, which is just like your vertical translation. Okay, if C is greater than 0, it moves up, just like in the warm-up. And if C is less than 0, it moves down. Okay. One thing to note, that what we now know is that we know the equation of axis, or axis, equation of axis is y equals c. That's one thing we've developed out of here that you're going to want to take with you. All right, so that's the C, or the vertical shift. Let's take a look at the D now, which is called your horizontal translation, or we call this phase shift in grade 12. All right, so we're going to examine the horizontal translation. Okay, and in your textbook they use phase shift. Means the same thing. Okay, and we're going to use the graphing calculator with the same settings. So if we're going to use our parent function of sine x, hopefully you know how to draw that by now. Hopefully you start at the axis, go to your max, axis, min, and back to your axis. All right. So that's our parent function. Okay. And the D value for that, ladies and gentlemen, equals 0. Okay. Let's plug that in our calculator to make sure we get the right get the right graph. So we're going to go to y equals. I'm just going to clear these keys, guys. So we're going to go clear, down arrow, clear, down arrow. Okay. So now we're going to type in sine x. So sine x. Okay. Doesn't matter if you have it in the first one or the second one. I've got it in the second one. It's not going to matter. We can still graph it. Okay. So double check. Hey, yes, that's what we graphed already. That's our parent function. Y equals sine x. Now let's perform some translations in the phase shift or the horizontal direction. So what does this say here, folks? It says sine x minus 30. So my value of d in this case, ladies and gentlemen, is d equals 30. Okay? So let's just graph that and see what similarities we know. And you could put down 30 degrees if you like. So let's go back to our graphing calculator. And you could go sine, opening bracket, x minus 30, closing bracket. Please don't put your degrees in here. It might just complicate things. Okay, so we're going to graph that. And before I do that, I'm just going to make it thicker so that it's easy to see. Okay, so let's graph it and see what happens. So it looks the same, but do you see the phase shift, ladies and gentlemen, how it shifted a little bit to the right? Okay. Everybody recognize that pattern? Okay, let's go back to our graph, or back to our lesson. So what's happened, folks, is it has shifted over 30 degrees. And because it's positive, it shifted 30 to the right. So instead of my starting point being here, I'm going to go 30 degrees here. Instead of my maximum being here, it's going to be 30 degrees here. Instead of my axis, it's going to be 30 degrees here. So I'm just moving all my key points over 30 more degrees. Okay? So I'm just going to do that. And then I'm going to draw my graph. Notice, folks, that it stays the same shape. It's just shifted over, okay? This is where it's really important if you have different colors to use it so you can see what's happening. All right, so make sure you got arrows at both ends. Okay, so what did we notice here, folks? And I'm just going to draw this. We call this the box or the starting point. So I'm just going to identify where did we start and where did we end to get to one phase or one cycle of our graph. All right, so just that helps us recognize our starting pattern. All right, let's try this next one here. Sine x plus 60. So again, the formula is regularly negative. So what does this tell us? D is negative 60 degrees. So what does that mean? Instead of starting at my origin, I'm going to go back 60 degrees. Okay, let's just be so you can grasp the concept, folks. We're going to go back to our graphing calculator, go to y equals, change this value into positive 60. Okay, and graph. So here comes our new graph compared to the parent function, which is right here. So notice it's shifted left, and it shifted left 60 degrees this time. Okay, guys? Good. So let's go back and fix that up. So for every key point, go over 60 degrees. Okay. So 60 degrees is kind of 2/3 of the way in between. Just it takes some time to do this, and it's worth the time to do it, folks. Okay. So we draw our smooth sine x curve. Okay. All right. Now, in order to do the starting position for this, D was at negative 60. So that's where we're going to start our box. And I always like to make one box bigger than the other when you're dealing with more than one. And then where does it end until we complete it? It's, just one second, folks. It ends right here. Okay, because that's where we've completed one cycle. Okay. So notice that these boxes are the same length because they represent the same cycle, but they're shifted over from each other. And if I try very carefully to put in my original phase shift, guys, it's right here too, which is going to be exactly the same size. These box lengths can change next day when we look at the A and the K part. Okay, so hopefully you get a good understanding of that. Let's just double check this using the cosine curve. So again, with cosine curve, ladies and gentlemen, you know that it starts at its max, goes to the axis, goes to its minimum, axis, and max. These are the key points you want to remember so that for a test it's easy to draw them. If you happen to try to get them mixed up, you can always say, hey, cos of 0, and it will give you 1. Whereas if you try sine of 0, it will give you 0. So if you get them mixed up, just plug it in your calculator, and that's an easy solution. Okay, so y equals cos x, that is our parent function, d equals 0. There's no shift left or right. It starts here at 1 on the y-axis. All right. We're going to try cos x minus 60. What does that tell us? That tells us that d equals 60. Okay, so if it's positive, that means we're doing a shift 60 degrees to the right. But again, let's use our technology to help us with this. So we're going to go to y equals. We're going to clear both. This time I'll try to get cos x first, so it's easier for us. Okay, and then the second one we're going to graph is cos, and we'll go x subtract 60 and close it. All right, so here and I'm going to change it to be a thicker line. Okay, and then we're going to graph it. So here comes our parent function, ladies and gentlemen. Okay, here comes our translated one. And notice, guys, the shift, instead of the maximum starting at the y-axis, it starts 60 degrees away from it. So when we're trying to graph that, I'm just going to say, hey, from my max doesn't start at the x-axis. It actually starts here at 60 degrees. So I'm going to shift everything over 60 degrees, okay? All right. So again, draw a nice smooth curve. Okay. All right. And again, if we're doing our phase shift, so let's say, where did it start? Right here. Where would it end? A little past here, okay? So it would end at 60 degrees plus 360, which would be at 4. So this would kind of be at 420, right? Okay. All right. Let's try the last one. See if we can do it without graphing, using the graphing calculator. Okay, so again, the formula is normally x minus d. It's plus, so that means that our d must be negative. So negative 30 degrees or negative 30. Okay, if we want to be consistent, we'll keep our degrees in. All right, so we're starting 30 degrees away from our parent function. So we're starting here. So for each key point, just start 30 to the left. Okay. And again, draw a cool, nice smooth curve. Okay. If I was to take a look at my phase or my starting point here, folks, we started 30 to the right. Sorry, my fault, 30 to the left. Okay. And where did we end up? At 330. There. It's important to know these boxes to know where to draw them so that you can help yourself with that. So again, we've got boxes to help us indicate where our values are. And oddly enough, folks, I don't know if you've seen this, but a lot of tattoo artists use the different transformations of the sine sine x curve or the cosine x curve or function to get some pretty cool tattoos. You may have seen someone that has bands like that. All right, and let's finish this off, ladies and gentlemen, discussing what we've learned about D. So again, D is what we call the phase shift. So D represents the phase shift. Sorry, spelling mistake. So phase shift, okay? And really that's your horizontal translation. Okay? What do we know, folks? That if D is greater than 0, we're going to move to the right. And if D is less than 0, we move left. Okay? And just remember, folks, that we've learned that the starting point is D. Okay? And just remember, folks, when x minus d squared, or sorry, not squared, depending on what degrees you're using there. Sorry, let me erase that again. Okay, so if it's x minus d, d is greater than 0. And if it's x plus d, d is going to be negative, so it's going to be less than 0. It's the opposite of what you see in the brackets, right? Okay, so hopefully that's going to help determine where we're going to start. All right, now let's put the challenge, folks. Let's try to combine the two of them. Are you ready? We can do this. Let's try to combine both the horizontal and vertical translation together, okay, without using a graphing calculator. Let's try it. Ha ha, we can do this without using it. We'll use a graphing calculator to check if you'd like. Okay, so first of all, we got to start with what's our parent function in A? Our parent function is, and we'll use, just to keep consistent, we'll say f at x, or y, equals sine x. So again, we're going to graph that, ladies and gentlemen. So we start at 0 for sine x. So we go 0, maximum, axes, minimum, axes. Okay. So draw a nice smooth curve. Here we go. Okay, put arrows on both ends. Okay, so from that, what do we know? We take a look at g at x, which is a transformation. That's why it's not f at x, because it's been transformed. We know two things. We know, first of all, that c equals 2. What does that mean? We're going to go up 2 values. And d equals 45 degrees, which means we are going to go right 45 degrees. So all I'm going to do is take any of my main features, and I'm going to, for example, I'll start at 0, 0. I'll start right here, okay? And instead of doing that point, I'm going to go up 2, and I'm going to go right 45. You guys good with me? Start at my maximum here. I go up 2, right 45. I go to my axis here. I go up 2, and I go right 45. Start at my minimum, go up 2 over 45. So hopefully you see the trend here, folks. And we can graph it Just by following the same patterning as it is. Okay. So here we go. Okay, the only thing is, just give me one sec. Try not to erase. Sorry. Let me back this up. I missed one point over. I forgot to go over here. There we go. All right, so draw your nice smooth curve here. Put arrows on both ends. So that is G at X. All right, so folks, the wave is exactly the same. However, it's been shifted up to and it's been translated 45 to the right. Other than that, it's the exact same one. Let's try this last one. H at X. So our parent function here is cos X. So we start at our maximum, go to axes, minimum, axes, maximum. All right, smooth curve. All right, now H at X, let's see what's happened to H at X. So H at X equals cos X plus 90 degrees. Notice the negative's now a positive there. That tells us D equals negative 90 degrees, which means we're going to go left 90 degrees. And C equals negative 1. That means we're going to go down 1. Okay, so for each key point, we're going to do that. This one's going to be a little easier with our graphing style that we have. Okay, so we're going to start at my maximum. Okay, I'm going to, instead of plotting there, I'm going to go left 90 and I'm going to go down 1. Start here. Go left 90, down 1. Okay. Gonna go left 90, down 1. Okay. So again, you start and you go left 90 and down 1. So left 90, down 1. Okay, left 90, down 1. And hopefully you see the pattern developing here, guys. Okay, so we draw a nice smooth curve. Okay. And there you have it, folks. I know that's been a long lesson, but there's a lot of things you should learn. Again, if you haven't done transformations in a while, please check back with your grade 10 or 11 notes on that, or I've got some posted on my website. But let's see what we've learned so far. So far, when we're dealing with D and C, we've got an amplitude that equals 1. The reason why is A equals 1 in all these cases. That's going to change when we deal with A and K next day. The period is 360. That's because K equals 1. And again, that'll change. But the things that will not change is your horizontal shift is D, which we call the phase shift. Okay. The vertical shift is C, and we've learned that Y equals C is your equation of axis. The domain is that X belongs to a set of real numbers, and the range is such that this is our minimum and our maximum. We're going to learn more about that next day when, again, A equals 1 here. And the only other part we want to talk about is that D equals what we call our starting point. So helps us graph. All right. So I know that was a long lesson. We were flipping back and forth with technology, so I appreciate your patience. Here's your homework, ladies and gentlemen, page 28, 29, numbers 3AB, 4AB, 5A, 6A, 8AC, 9EF, and 13. Give that one a try. Good luck, and again, come see me as always if you need some extra help. Have a great night.